Let's see concentration of solutions. So concentration is going to tell you how much of a solute is there in a certain amount of solvent. So for example, if you have two solutions of sugar, so let's say the red one is sugar and the blue one is water. So in solution A, you see there's more sugar particles and less water particles, which means that it's more concentrated in sugar. There's more solute, the solute is the sugar, than solvent, and the solvent is water. So if there's more sugar than water, means it's concentrated. If you have more water than sugar, so here you have more solvent, so you have more water, more blue particles here. So because you have more water than the sugar, means it's more dilute. So concentration is going to give us an idea of how concentrated, how dilute something is, a solution is. So actually it's the amount of solute. So the solute could be an acid, could be a salt, could be sugar, could be any substance, amount of solute per unit volume of solvent. Amount of solute is either measured in mass, so it's how much mass, how many grams of solute you have per volume, or it's also measured in moles. How many moles of a substance do you have per volume? And the unit volume, it's in dm cube. So the unit volume is in dm cube. So concentration is the amount of solute, so the mass of solute per volume. So it's the gram per volume, or it's the moles per volume. And that volume is 1 dm cube. So it's how many grams you have in 1 dm cube, or it's how many mole you have in 1 dm cube. So hence concentration has the unit gram per dm cube or mole per dm cube. So it's how many mass you have per volume. Per means divide. So mass per volume, or its number of moles per volume. So these are the formula actually to calculate concentration. Concentration is mass in gram divided by volume in dm cube, or number of moles of that substance divided by volume in dm cube. And for this formula especially, you should know how to convert centimeter cube to dm cube, because most of the time the volume is going to be given to you in centimeter cube. So centimeter cube, to convert it to dm cube, you need to divide by 1000. dm cube to centimeter cube, you're going to multiply by 1000. Let's see one example. So what is the concentration of an aqueous solution in mole per dm cube? So mole per dm cube, so you will need to find the number of moles and you will need to find the volume. You are given 50 grams of NaOH. So here you're given the mass. So from mass, you can find the number of mole, because you can see here, you're going to need the number of mole at one point to get the value in mole per dm cube. So from the mass, you can get number of moles. Remember, number of moles is mass over mR. So you know the mass, you know the substance, so you will know the mR. So mass over mR, you will get the number of moles. And this was dissolved in this volume of water. So this volume is in centimeter cube. So you will need to convert it to dm cube because you will need the volume here. So let's start to work it out. So what is the concentration? Concentration is the amount of substance in mole. So number of mole divided by volume. So what is the number of mole? Number of mole is mass over mR. But what is the mass? It's given here, 50.0. What is the mR? You will need to calculate it. mR of NaOH. If you calculate it, so it's AR of Na plus AR of O plus AR of H. So that's 40. So 50 divided by 40. So 1.25. The volume is in centimeters. So volume, I'm going to convert it to dm cube. So divide by 1000. That gives me 1.5. So this is 1.25 divided by 1.5. And I get 0.8 mole per dm cube. This is going to be my answer. Now, some students, they convert the volume directly over here. So you could also write concentration is 1.25 divided by the volume in centimeter cube divided by 1000. Because it's divided and then divided again, so it becomes multiplied by 1000. It's going to give you the same value, 0.8 mole per dm cube. It's just that you're eliminating this working and you're doing it over here itself. Okay? Let's try the second question. Calculate the concentration in mole per dm cube of 40 grams of sodium carbonate dissolved in 500 centimeter cube of water. So concentration is number of moles divided by volume. Here, number of moles is mass divided by mR. So mR of sodium carbonate, if you calculate it, is 106. Yeah, 106. So you get 0.38 mole. Then concentration would be 0.38 mole divided by volume. Volume is 500 centimeter cube. Convert it to dm cube. Divide and then divide again by 1000. So that makes multiply by 1000. So you get the answer to be 0.75 or 0.8 to 1 dp mole per dm cube. So that's for part A. Try to do part B. It's the same way. And check your answer. For part B, you should get a value of 0.7 mole per dm cube. Pause the video, check your answer. I'm going to try to do part C now. So part C, it's a bit different here because here you're given volume of HCl solution, volume of HCl gas, which is completely dissolved in 3000 centimeter cube of water. So water is the solvent and HCl is the solute. So for you to find concentration, you will need the number of moles of solute divided by the volume of solvent. But you are given the volume of the solute. How can you get number of moles from volume? Remember that number of moles is volume divided by 24 dm cube. This is why you need to know your formula well. So volume is 1000 centimeter cube. So you will need to convert that to dm cube. So that makes 1 dm cube divided by 24. That's the number of moles. So the concentration would be number of moles divided by the volume of the solvent, which is 3000. So 3000, and then divide by 1000. So multiply by 1000. So that gives you a concentration of 0.013 mole per dm cube. That should be the answer for the third question. Now, in this case, you see you're calculating this value on your calculator and then using it again. What I would suggest you is that when you're using the values on your calculator, if it's a whole value, you just press answer divided by 3000 and then multiply by 1000. Because if you, let's say someone puts 0.004, let's say someone uses 0.04 instead of this value, the answer is going to be slightly different. So you're going to lose some accuracy marks. So it's better to use the value from the calculator itself. Use answer divided by the volume. Okay? Try to do question number 3. So question number 3, you are given the concentration, you are given the volume, you need to find the amount. Find the amount in moles. So concentration is number of moles divided by volume. Therefore, number of moles is concentration times volume. You know the concentration, you know the volume. Be careful, you need to convert this to dm cube. If you do this well, you should get 0.6 moles. Question 4, you need to find the mass dissolved in 5000 centimeter cube. This is in centimeter cube. You will need to convert this to dm cube. So volume in dm cube. This is the concentration in mole per dm cube. Be careful. So concentration is given, but concentration is given in mole per dm cube. You need the mass. So concentration is number of moles divided by volume. You know the concentration, you know the volume. Therefore, you can find the number of moles. Number of moles is concentration multiplied by volume. From the number of moles, you can get the mass. So, number of moles is mass over mol. Therefore, the mass would be given by number of moles that you just calculated here times the mR. And the mR here, you calculate it for CaOH twice. So, calculate the mR for this. And then you multiply it by the number of moles. This should give you the mass. If you do this properly, you should get 1.85 grams. For question 5, so here again, you're given concentration in mole per dm cube. You're given volume in centimeter cube. You need to find the mass. So it's in the same way as question number 4. So try to work this out on your own. You should get a mass of 22.8 grams.